Okay, today we're going to learn about long division and synthetic division, which are division techniques for polynomials. So if we're dividing one polynomial by another, we can always use long division. Synthetic division I'll talk about when we get there on in what cases you can use synthetic division, which is kind of a shortcut method. So before we do long division with polynomials, let's just review how long division with numbers works, because it really works the same way. So if we understand how long division works with numbers, that'll help us a lot. So for example, if I had 3 divided into 71, okay? When we're doing 3 into 71, we really just look at the first number. So 3 into 7. How many times does 3 go into 7? Twice. And then 2 times 3 is 6, so we write the answer there, and then what do we do? What do we do after we write the 6? We subtract, don't we? Subtract. 7 minus 6 is 1, and then we bring down the next number, which is 1. 3 goes into 11. 3 times. 3 times 3 is 9. Subtract and we get 2. And so that means 71 divided by 3 is equal to 23 with a remainder of 2, which means it's 23 and 2/3. 23 and 2/3. When you were in elementary school, you just wrote 23 remainder 2. But now that we're big kids, we can write it as 23 and 2/3. I put the 2 over the 3. Okay? We can also say that 71, take a look at this because we're going to do this with the polynomials also. 71 is equal to the product of these, 3 times 23 plus the remainder. 3 times 23 is 69 plus 2 is 71. Okay? So the quotient is this. We can also write it as the product of the two whole numbers, 3 times 23 plus the remainder. Okay? So we'll write it, when we do these with polynomials, we'll also write it in both of those formats. Okay? So now we'll do the same type of thing, but this time with polynomials. And so first, we're going to write x minus 4 divided into 3x cubed minus 5x squared minus 3x plus 2. Raise your hand if you've done these before. All right. So we're going to put something here. Did I miscopy something? Oh yeah, plus 5x squared, is that what you mean? Yeah. Yeah, thank you for catching that. Okay. And so we need to put something in this box so that when we multiply it times x minus 4, it's going to give us, the first term is going to be 3x cubed. So what can I multiply an x by that's going to make it into 3x cubed? 3x squared. So that's the first thing that we're going to put here, is 3x squared. Now I multiply that times the x minus 4. That gives me 3x squared minus, sorry, that gives me 3x cubed minus 12x squared. Now when we did it with numbers, we said after we multiply, then we subtract. So I have to subtract all of this. Now this is the step where a lot of people make mistakes. So we have to be really careful at this step. So 3x cubed minus 3x cubed, that's 0. What is 5x squared minus negative 12x squared? That is 17x squared. Minus minus makes it a plus. And then, just like we did with numbers, we'll bring down the next term. And then we repeat the process. So what do I multiply an x by to make it into a 17x squared? 17x. And that becomes 17x squared minus, what's 4 times 17? 68x. And then we subtract all that. So that ends up being 65x. Bring down the 2. Okay, what do I multiply x by to get 65x? 65. And so that's going to be 65x minus 260. Then we subtract. And we get 262 as our remainder.
Why does that go to subtract? Because it's plus 2 and then it's negative 260.
We always subtract what we get after we multiply. Just like with numerical division,
Okay.
if you did 5 into 277, that goes in 5 times, you multiply, you get 25, and what do? Subtract, right? So we always subtract. Bring down the 7, goes in another 5 times, 25, subtract, and you get 2. Okay, so we're always subtracting at that step. So our remainder is 262. So now we're going to write our answers in the form, let's see, let me create a little bit more space here. Question, Adam?
Yeah, so if it was x plus 4, then would, like, for say 65x minus 260, would it be 65x plus 260? If you had an x plus 4?
Mm-hmm. Yes. But the whole rest of the problem would have been different also, but yes. You multiply whatever we put on top, we multiply by this expression, x minus 4. Okay, we'll do some more examples, but now that now we're ready to write our answer. So we're going to write our answer like this. We're going to have dividend equals divisor times quotient plus remainder, just like we did with the numbers up above. See, up above we did this problem and we wrote 71 equals 3 times 33, that was the product of those, 3 times 23 plus remainder 2. And that 71 equals 71. Okay, so we're going to do that same thing here. So our dividend, that was the original problem, 3x cubed plus 5x squared minus 3x plus 2 equals divisor, that's x minus 4, times quotient. So basically we're just multiplying these things up here. So divisor times quotient plus our remainder, which was 262. Okay, so that's the way we're going to write our answers. Any questions so far? Okay, we'll do the next one together also. Okay, so same process. We're going to first need to figure out what we can put up here so that when I multiply it times x squared, it's going to give me 4x cubed. So discuss in your groups right now, what would I put in that circle? So I think I heard several people say we need to put 4x there. So if I put 4x there, and then I multiply by the entire divisor, 4x times that divisor gives me 4x cubed plus 12x squared plus 4x. And then we're subtracting all of that. So 4x cubed minus 4x cubed is 0. 2x squared minus 12x squared, what's that? Negative 10x squared. And 3x minus 4x, negative x, and then bring down the 5. Now what's the next thing we're going to multiply by up on top? Negative 10. Negative 10, if I multiply that times that, that's going to give me negative 10x squared minus 30x minus 10. Now we subtract. Everyone go ahead and do that subtraction. Hopefully you're writing in pencil. Marissa, what'd you get? Positive 29x plus 15 is correct. Okay, questions on that? Now if I tried to divide x squared into 29x, x squared is a bigger exponent than x, so that means I'm done. I can't divide in anymore, and so I'm all done, and now we're ready to write our answer. So 4x cubed plus 2x squared plus 3x plus 5 is equal to the product of those two things. So that's x squared plus 3x plus 1 times 4x minus 10 plus our remainder. Any questions on that one? Okay, now when we write these problems in the division format, 3x squared plus 6x plus 1, when we put these polynomials in, we want to also check to see if there are any terms missing. So this one, if we look at the polynomial 15x cubed plus 8x minus 12, what term is missing? What power? There's no x squared term. So what we do is we insert 0x squared, and that'll be useful as a placeholder. So we're going to have 15x cubed plus 0x squared plus 8x minus 12. Okay? So anytime you're missing a term, you want to fill it in with a 0 placeholder. So I'm going to go ahead and let you guys try that one, and then I'll come around and help you if you need it. Put your hands up if you need help. So we need to start by multiplying by 5x, and so that's going to be 15x cubed plus 30x squared plus 5x. And then when we subtract, we get negative 30x squared plus 3x, bring down the minus 12. And now we're going to multiply by negative 10. negative 30x squared minus 60x minus 10. Subtract. We get 90x minus 2. Do you agree? Oh, not 90. What is that? That is 63x. Sorry. Don't know where the 90 came from. 63x minus 2. And that's our remainder. And so now we can write our answer as 15x cubed plus 8x minus 12 equals 3x squared plus 6x plus 1 times 5x minus 10 plus the remainder. Okay, questions? All right, try this one. Okay, go ahead and compare your answer with what I have up here.
You could, but you want to go with you could, I mean, anything times, like, for example, okay, so if PO
Is that supposed to be a 7x?
exponent is greater than,
Um,
it's about h plus
No?
you could, but
Yeah.
it's one time, what do acids do with h plus ions, what do bases do with h plus ions?
Okay, any questions?
What do acids do, like, release or
Okay. Now, in this last problem,
do they release or
we were dividing by just a binomial, x plus 5, and also in the first problem we were dividing by a binomial. When you're dividing by something of the form x minus a, we can do something called synthetic division, which is kind of a shortened process. It doesn't work for all polynomial division, only when we're dividing by something of the form x minus a. So synthetic division is used when dividing by x minus a. And so we're going to do that. We're going to do the same problem we just did. As you noticed, we got some pretty big numbers, and so it would be nice if we had kind of a simpler process when we're dividing by a binomial, because there's a lot of opportunity for error when we're adding and subtracting those big numbers. And so we're going to do the same exact problem, but this time using synthetic division. And so the way synthetic division works, first you figure out what a is. So what are we subtracting from x in this case? If we think, so x plus 5 is written in the form x minus a, what would a be? So a equals negative 5. So we put negative 5 out here in a box. And then we write the coefficients of the dividend across the top. So the coefficients are just the numbers in front. So that would be 7, 0x squared, negative 6, and 9. So I'm just going to have you put your pencils down and watch for the first one. And then once you see how the process works, it's just the repeated algorithm that we do over and over and over again. Once you see how that algorithm works, you'll be able to pick it up for the next one. So I'll give you time to write after you watch this. So pencils down, just watch for a minute. So the first step is to bring down the first number, 7. And then we're going to multiply negative 5 times 7. So that is negative 35. And then we add vertically. So 0 plus negative 35, we add those and we get negative 35. And then we multiply again. So we just repeat that process over and over. So negative 5 times negative 35 is positive 175. add, and we get 169. Multiply, negative 5 times 169 is negative 845. Add, that is negative 836. And so compare those numbers that we got with the answer to the last problem. Look at the answer that we got up on top. 7x, I'm looking up at the very top there. 7x squared minus 35x plus 169. Those are the same exact numbers that we have down below. And so this 7 means 7x squared because we had an x cubed divided by an x. So our answer should start with an x squared. And then this means negative 35x. This means plus 169. And this is our remainder, negative 836. That's the same remainder we got when we did the long division method. But if you'll notice, this method is a lot simpler. You just multiply and add, multiply and add, multiply and add. And so then we could, of course, write our answer the same way, which was 7x cubed minus 6x plus 9 equals x plus 5 times 7x squared minus 35x plus 169 minus 836. Okay? So you can go ahead and write down whatever you need to write for this one, and then we'll try another one together. Don't staple that on. Do you need a pass or anything? Hold on. You need a pass?
Yes, please.
Okay, any questions? Yes, Timothy?
By just using this method, how do you know it's starting with x squared again?
Because we're dividing an x cubed by an x. X cubed divided by x is x squared, so that tells us our first term needs to have an x squared in it. Does that make sense? Okay, any other questions? All right, let's try another one. Yeah, go ahead.
Does it have to be like only an x plus something?
Yes, you can't use synthetic division unless it's of the form x minus a. That's the only time that method works. So, for example, if we go back and look at example C that we did earlier today, we wouldn't be able to use synthetic division for that one. But if you look at example A, we could have done example A using synthetic division. Okay? All right, so let's go on to another one, and we'll do this one together again. So we're dividing by, yes?
So is A always going to be the opposite of what it is? So it's plus 5, it's going to be minus 5.
Yes.
And it's minus 5, it's going to be plus 5.
Yes. Okay. So what's A in this problem? A is 2. Oops. There we go. Okay, A is 2. And so we put 2 out here in the box. We write down the coefficients. 2, negative 3, 5, negative 8.
Don't you use 0?
You're right, we need a 0. We need a 0 for the x cubed term, so 2, 0, negative 3, 5, and 8. Negative 8, thank you. Okay, does that look right now? Alright, so now we bring down the first number. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. Okay. Questions so far? Should we do that again? You got it? Multiply and add, multiply and add. That's all you do. Okay? And so, what is our first term going to be? We have an x to the 4th divided by an x, so it's going to start with an x cubed. So that's going to be 2x cubed, and then it's going to count down from there. 4x squared, 5x, 15, and the remainder is 22. So we write our answer as 2x to the 4th minus 3x squared plus 5x minus 8 is equal to x minus 2 times this answer, 2x cubed plus 4x squared plus 5x plus 15 plus our remainder 22. Any questions? Okay, go ahead and try example C using synthetic division. So what number are we going to have in the box? Negative 3, and then we're going to have, are we missing any terms?
No.
No, so we're just going to have 1, 3, negative 4, negative 12. Bring down the 1, multiply, add, multiply, add, multiply, add. And so then this, our first term is going to be what degree? Squared. So this is going to be 1x squared, 0x minus 4 with a remainder of 0. Okay, what does that mean if you have a remainder of 0?
It goes in evenly.
Yeah, that means x plus 3 goes in evenly, so that tells us that x plus 3 is a factor of x cubed plus 3x squared minus 4x minus 12. And that's one of the reasons why we have been writing these answers in that strange way. We'll see why in just a second. So if I write this answer in that same format that we've been using, we have the original problem equals x plus 3 times our answer, which is x squared minus 4, plus our remainder, which is 0. Okay? So since x plus 3 is a factor, I was able to write this original expression as x plus 3 times the quotient, which is x squared minus 4. And do you see how that can be factored further? Yeah, x squared minus 4 is a difference of squares, so we can write that as x plus 2, x minus 2. So hopefully now you see a connection between what we were doing yesterday, which is factoring polynomials. Now that we're doing division, we see how the two are related. If we can divide and get a remainder of 0, we just found a factor. Okay? So once we find a factor, then we can take the remaining factor, which in this case was x squared minus 4, and factor it again, and now we have x cubed plus 3x squared minus 4x minus 12. We have it fully factored. And it all started with synthetic division. Okay, so we tried a factor, it got a 0 remainder, which means it is a factor. And so that was the start of us being able to factor this polynomial. So yesterday we had a problem that we couldn't do using grouping. Remember, we had a grouping problem that didn't work? So if you can try some different factors that you think might go in, you can use synthetic division to try them out, and if you get a 0 remainder, you'll find one factor, and as soon as you find one factor, then you'll be able to take the smaller piece and factor it separately as well. Okay? So that is it for today's notes.